Hey, welcome back. Good to see you again. Thanks for joining the channel. Hope you're all well. So today on the bench, I have something a little different. It's a kit that I purchased on Aliexpress. And I've been watching these for quite a while, keeping my eyes on them. I've been wanting to get one for a long time, but they've been very expensive. And I kept my eye on this one, and they kept dropping the price. But that's not always a good thing when you pay a low price. But anyways, I've been itching to get one. Finally got it. Satisfied my curiosity. Curious on how they build, how easy they are to put together. Curious on how they sound, how they perform. Yeah, let's just get into it. So this is a tube amplifier, and what do we got here? It's all Chinese, but let's cut into it. Let's go here. I need a sharper knife. Let's get a sharper knife blade. Okay. Let's see here. Let's cut this here. Let's cut it here. Okay, so what do we got? Cut this here. Alright. Let's see how this is packed. Let's pull it all out, I guess. Let's do this. Packed like this. Let's just dump it like this. It is quite heavy. It comes in at, if I can get a weight on it, here it is. And I'm greeted with the smell of fresh paint. It doesn't say how much it weighs, and I forgot to weigh it, so whatever. So let's get rid of this packing material. Packing material. Okay. Packing material. Let's get rid of all this. Now, what are we left with? Looks like we're left with 3 transformers. And this looks like our chassis. That's heavy too. It's packed well. Oh, it's got the wooden sides. Cool. Make it look really good too. We'll get to that. So that is authentic wood. What kind of wood is that? I'm not sure. But those are the wood sides. They're nicely finished. A few blemishes on them. We'll put that aside. And what do we got here? Packed well. This is the power transformer. Input. I've got 210 volt inputs, and we have a 240 volt, or actually it's a 480 volt center tapped outlet. 3.15 volt center tap for filaments, and another 6.3 for filaments. Okay, so that's a nice looking little transformer. assuming these are our output transformers. Yeah, I've always been wanting one of these, and I think make a nice Saturday morning project here. We can put it together and build it and test it and see how it sounds. Oh my god. Okay. Industrial tape. Whew. Stinks with paint. Okay, so 5k ohms. You can read that, can't you? 5k ohms, and we have 4 ohm, 8 ohm outputs. This will be one of those, and this is the other one. There's some kind of terminal strip. Printed circuit board. Let's open this up. I don't want to scratch the chassis. That's the problem here. Get this open without scratching it. Well, this is the bottom, so it's cut here. Sure, wrap it well. Got enough tape on this. Okay. So we got a little bit of damage to the bottom plate, but that's no big deal. We can straighten that out. And the top of the chassis looks okay. Looks like it's made out of stainless. It's coated with plastic. Okay, let's have a look here. Another terminal strip. This one's funky. Interesting. Okay, there's our chassis. Put that aside with our wood. That's what it's going to look like. Pretty hot. Okay, so we have, I'm just going to put everything in this tray here, just so nothing gets lost. And let's have a look at the documentation first. What is that? These ceramic tube sockets? That's a good, kind of like that. I wonder if that's CSA approved. So we got lots of goodies. I don't see any integrated circuits, so we're all good there. Okay, so let's put this aside. This will do me a lot of good. Okay, I guess this is our only help. Wow. Okay. This is going to be interesting. Well, let's start with the power supply. Looks like it's wired for 220, but we're going to do it 110. A 2 amp fuse, switch, input. We have an input connector with fuse. I wonder what fuse is in here. No fuse. Oh, we got a fuse. Two amp. 2 amp. That is not what we need for 110 volts. Okay, so we have our 240 volt winding, 480 volts center tapped, and those goes to these two. There's 2 rectifier tubes, 263 volts output. Where B plus is 245 through our filter network. Here's the diagram for 110 volts. They're still using the same 2 amp fuse. Switches on the fuse side, and then our 2 coils. So maybe we could get started doing that, putting our power supplies together. Really not much help here. This is useless. A parts list, I think. All right. Let's peel off the protective coating here, because once we start mounting parts, we won't have the opportunity to do this. And let's have a look at condition of the chassis. Oddly satisfying when you pull this protective film off. Actually, that's pretty good. Okay, I can see some damage here already. So, we got some damage here. It's a little squished down. You can see that. What I'm going to do is straighten this back up. Just get a... Just bring this back up a little bit. Not bad. Yeah, this is minor. A little crushy in shipping. Gotta be careful, these are very sharp. They're all just stamped with a die cutter, and yeah, they're very sharp. Somebody very sharp. Alright, so first thing, I think I'm gonna have to pre-drill these so that we have our holes lined up. I think I'll mark and drill these, and then I think I want to install them before I put my connectors in, because once I start putting connectors and stuff in, you won't access the screws. So I want to put the sides on first, I believe. So let's do that next. I'll mark and drill these. Now, do I want it flush on top, or do I want it proud on top? Like that, or like that? I think I'll put them flush on top. Okay. Okay. So these are the screws I'm going to use. They're looks like they're a very short wood screw. And I'm going to get the diameter of them. 0.106. Okay, so let's get a drill bit for that. Not going very deep. Maybe a 1/4 inch. Okay, step 1 completed. Put the wood sides on. I think it looks rather sharp, rather smart. It's a nice brushed stainless steel chassis with some wood sides. And it's got a good look to it. So let's start wiring this thing up. We're going to have to do some, install that. Be your first step, I think. Let's put this in that way. There should be some hardware for this. The hardware they give you is not the finest. It's the cheap hardware that they can get. If that's something that bothers you, you can always upgrade it. Step 1. Now we need a power switch, I do believe. Okay, so that is on. I want it facing up when it's on. I'm just going to put this in loose, just so it's in the right position. I'll remove it when I want to do the wiring. I'll just put this on loose for now. Okay. And some M4 nuts on here. Okay, so I cheated a little bit. I went on the website where I bought the amplifier, or the listing, and they did have some photographs of how it should look. We have a terminal strip down the middle here, and beside our tube sockets. That's where our wiring is going to happen. And our power supply is here, and these are rectifiers, I believe. So what I'm going to do is I'm going to, and here's another point-to-point diagram. Gives us pretty much everything we need to know. It's a little messed up, but whatever. What I'm going to do is I'm just going to go through and mount all the components, like the tube sockets, the connectors in the back, volume pot, all this stuff I'm going to mount. Okay, so just chugging along here. I just put all the tube sockets in, and yeah, I'm not impressed with the hardware. It's not the greatest hardware, but if you want to substitute your own hardware, you're welcome to. It doesn't look that great. They're a little sharp. It's not the greatest hardware. But got those on. They're loose. I have to torque them down. Let's see here. I position the lugs so that the ground lugs are together, and then I can just run one wire through the middle of the tube, and that'll clean up that wiring. There's a switch that goes in the middle here. But I ran into a problem. Let's see here if you can see. They give you this. This is a terminal strip with the lugs on it, and some of these lugs are loose, and which is perfectly fine. Once you attach your wires, they're not going to go anywhere. And they also give you this PCB board terminal strip that you can use in place of this. You got a choice. They're drilled the same. They have the same number of connectors, but they don't fit the chassis because the holes aren't drilled properly. So if I line up this hole here on top, you can see the one down below there is out by about 1 inch. So I'd have to drill that hole out. And then the hole down here doesn't even come close. It is out by about 3 or 4 centimeters. So what do I do here? I think I have to move this into this position, drill a hole here, and drill a hole here, down here. I'm really not happy about drilling holes in this stainless steel, since it's all punched, and then I'll have 2 holes that appear to do nothing. So I'll get on with that. Haven't decided whether I'm going to use the terminal strip or the PCB board. This one's a little more rigid and thicker. This one's a little thinner, and it's hard to say. But this is supposed to be hanging off the chassis. So they give you some long screws here. And these are, there these 30 millimeters. 20 millimeters. And I think they come from the other side like this. Put a nut on there, and then put another nut and secure your strip, and then put a final nut on top, and that puts it up above the chassis, probably about 15 millimeters or so. Could do that, or I could just get some standoffs. I got standoffs here. I could use something like this, plastic insulated standoff. This one here is about 15 millimeters, I think. It's 12 and a half. But this will work. And you can use a regular screw from the top, so it looks normal, and then I can put a nut on the bottom to hold it, and then it's insulated, of course. So I think I might go that way. Find 3 of those, and I do have 3 of those, so that should be good. So looking at this, I'm going to need, how many connections am I going to need? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to need 8 of these. I'm not going to use all of them. I think I'm going to go with the PCB strip. But first I have to drill some new holes to get this to work. I'll mark out the new holes and then we'll drill that. Okay, so I went to tighten down the transformer, and a lot of these bolts are loose, so let's go through and tighten them before we get too carried away here. Let's see how loose this is. Just snug these down really good. And hopefully this will eliminate any hum that was going to be present. Okay, now I can go back in. So here's a look at what I did. I drilled 2 holes and I mounted these insulated standoffs on it with some hardware. And I also took 3 of these little things apart and mounted them here. This is going to be my ground starlet. There is a spot here in the middle where we have, I got a star ground. So I just put that on the chassis just for use there. And then this piece will get mounted over top. We'll still have access to the star ground from below, but that's what that will look like. Coming together slowly. Another thing I'm going to do here, since these holes are so sharp, I'm going to put some grommets in here, but I'm trying to figure out, the hole is 8 millimeters. This one here is too big. That is 9.5. That's not going to work. I have some other ones here that are 8. These ones look good. Yeah, those are just under 8, so let's try these. Put 2, if I have any more of those. Alright, now we can start putting these on. That's a little bent up. Let's see here, that hole and that hole. And the other one. Okay, I'll feed the wires through, get some nuts and bolts happening, and get those mounted. Some of the hardware is really rubbish. I had an M4 nut that's all stripped out. It was oversized. So I had to replace that. That was no minor thing, but just little annoyances like that. So just going through and tightening down everything. And there's a crack. What's going on with that? But yeah, it's going. Why is this stuck? Not the highest quality components, let's say. Like for the example, these binding posts. Yeah, they'll do the trick, but just want to make sure that they're all tight first. And they did supply me with grommets. I was looking here, saw these grommets, but they're pretty shoddy quality. I have to trim them up if I wanted to use them. The ones I used are better anyway, so go through and tighten this. I'm going to tighten everything up. Terminal strips installed. Transformers are bolted down. What else do I have to do? I got the volume pot yet. I haven't decided what I'm doing with this. Looks like it's a PC mount one. I don't see the PC board in here, even though... Oh yeah, there is a PC board. So we'll get that soldered up. And then after that we can start installing components. These caps, these are fakes. These are not Nippon Chemcons. Let's have a look at this. Now if you look at the symbol, it looks like Nippon Chemcon, but it's Nippon Nivacon. I can't read it. These are fakes, and they're supposed to be 330 microfarad, but they only test out at, let's see here. They test out at 242, this one. It's got 68 milliohms of ESR, which is okay, I guess. So that one is that. Let's see this one. This one's 238 microfarad, 42 milliohms ESR. So I'm probably going to toss these aside and put something nice in, something quality. I haven't checked these other ones. What's this here? This is a 22 microfarad. Nichicon. Says Nichicon on it. And it comes out at 22.94, 42 milliohms. That one's good. That's legitimate. 105C. 50 volts at 100 microfarad. These are 105C as well. Where's negative? Okay. 20 milliohms, which is good. 97 microfarad. 98 microfarad. 20 milliohms. Those are good. Just the two main filter caps are going to get replaced. 0.33. Comes out at 340 nanofarads. It's good. Well within tolerance. 342. So everything's good that way. I'll check all the components before I install them, even the resistors, because some of these resistors could be kind of dicey. They're the cheapest ones you can buy. So I was having a look at these output transformers, and they're not really, you see this is up. See how that's up? It should be crushed down. So I'm going to take this out to the garage and stick it in a vise and crimp this down. It's really loose, and the end caps are loose too. So it's kind of wasn't put together very well. But I'll, like I said, I'll crush this closed and make that tight. All right, here's a look at the input connectors. I was tightening them down, but that's with the nut tight. That's unacceptable. I'm going to have to go and redo this somehow. I think the washer has a little bit too much of a shoulder on it, and this panel's a little bit too thin for these connectors, so that's why they're all loose like that. But I will get them down tight. Kind of less than impressed with some of the components they give you. This tiny little thing is a volume pot. I guess it'll do its job, but if you want something better, you're going to have to cough up some cash, because these aren't cheap to get a good one. This is probably, I don't know what these cost in volume, but they're probably like $1 a piece. Anyways, let's assemble this. What do we got here? This goes like this, I take it. Snap that in there. There we go. And then solder this up. Okay. But that's what they're going to do to keep costs down, is they're going to give you the cheapest parts they can get, and they buy them in volume, and then they assemble the kits. And this is what you get. It'll work. And if you don't like it, you can replace it with something better. I'm just going to go with it for now because I couldn't be bothered to look for another one. And it's got a nice little feel to it. It's got detents when you turn it. It's not bad. Alright, just about done here. Let's put this in. What's going on here? Maybe it's that way, or all the holes punched out are okay. So it's going to have to go that way. But we'll, unless I re-drill the front chassis, which I'm not going to do, it only fits in one way. So that's it there. And you can see I have the solder from the side, which isn't too bad, I guess. Alright, so I think we're just about ready to start our wiring. I think I have everything mounted. Everything's on the back, everything's on the top. Ooh, it's heavy. Everything's on the front. Okay, so the next big thing to mount is our filter capacitors. And they give you these double-sided sticky tape things with plastic. I don't know if I trust these. They might be good. They might hold for a year or two and then they fall off. How many did they give me here? They give me a whole bunch of them. Let's see, 1, 2. Wow, they give me a whole freaking handful of them. So this is what they gave me. They gave me a whole bunch of these. Now I'm supposed to use these for cable ties too. I can use some of those for cable ties. But let's see here. Where's my picture? So if I examine their kit build here, they have probably 2 on each capacitor to hold down these big cans. And then they had 1 here for this little cap. And that's it. They used 5. And they gave me like 20, I think. 15. We need to figure out, I'm not using these capacitors they gave me because these are fake imitations, and they measure down around 200 microfarads, not 300, so they are garbage as far as I'm concerned. Plus these are used poles. If you really look at them, somebody's taken these out of equipment. There's solder on the tabs and they've been pulled out of something. If you look at them, if you look at a new cap, I pull out a new cap and look at these connectors and they are just tin plated, but this has got solder on it, so I'm not using these used caps. As far as I'm concerned, these are trash. So what I plan on doing is I have a pair of these and we're going to upsize them too. So I got a 470 and I got a 620. Now I know I can't just put a 620 in and then expect the rectifier to charge it up. So I'm going to put this cap, let's see here, I'm going to put this cap second, and it's going to be after this 180 resistor, and I'm going to put this cap first, and it's going to be after this 51 ohm resistor. So that should cushion the intake inrush current and allow a good reserve of B+, a really nice reserve of B+, probably more than what I need. This amp will probably run for a minute after I switch it off, but it'll be very clean filtered DC when I'm done. So let's figure out where we can mount these two beasts. And there's really not a lot of space here. I think what I might have to do is something like that. Or that. That's not ideal. That's not ideal at all. Can't do this. Just not enough room. Boy, oh boy. Let's see here. This is not enough room. this maybe. Not enough room, not enough room. Might have to go with a smaller cap. Ooh. Like this maybe. I'm trying to keep away from having long wires, but we'll do whatever we need to do. Can mount this one here and this one here if it'll allow me. Or maybe it mount it like that. Probably like this. Okay, I'll put this one here and straddle over this. I'm just trying to think of if you ever have to come in and service this thing. That's too close to the socket. That's no good. Where else? I have room under here, but that's getting close to my speaker output, so it should be okay. I can insulate that. I wonder, maybe this is the solution here. Yeah, I think this might be it. Alright, I'll go with this. Okay, I think before we start mounting caps in their place, I'm going to do some basic ground wiring here. I want to get this set up for ground. So let's do this. It'd probably be quicker if I took that lug off the chassis. It'd heat up a lot better, but turn my iron up. Turn my iron up to max. Oh, come on. There we go. Okay. Now I'm going to take this lug and turn it around. So I don't want it facing that way, I want it facing the other way. There we go. Let's do the earth connection. Okay, now we've also got this wire coming out of the transformer, yellow with a green stripe. That's a ground shield. I'm going to attach this to the ground as well. Now I've gone through with an ohm meter, made sure this is not part of a winding with one of the others. And go through and double check that again just to make sure. Yes, I've gone through and I made sure that this wire is isolated from all the rest of these. So this is definitely a ground connection. So let's trim this one and mount it on the lug. Okay. Mount this one on the lug as well. See what I'm doing here. Okay. Give it that. difficulty seeing what I'm doing here. That's the problem. So make sure I got a good joint. It should be good. So that's the first step. Our grounds are in place. Move this out of the way. Put this one right about here. Crooked. And put another one right beside it. I'm going to use 4 or 5 of these things, maybe 6. Put that there, so I want this to go here, and that'll sit between them. Okay, so this cap will go here, and this cap will go here. The negatives will go down. And where are the negatives in series here? I think I'm going to add 2 more back in there. One right up here. I don't know if I have any faith in these things. They might let go after a while. That's why I'm putting so many. Gives it a better chance of survival. And then the next one will go up here. All right. Where's my other cap? They're not straight. Everything to look so pretty. Okay, I'm going to zip tie these down, and then I'll zip tie these down, and then I'll come back and we'll start wiring up our secondary power. Or actually, we'll do our primary power first. Okay, so I zip tied both these in. They're pretty secure. They're not going anywhere. As long as those adhesives stay stuck to the stainless steel, we'll be okay. Now I also added my ground wire from both negatives up to the star ground, so that's all complete. And now I just have to focus my attention on the primary circuitry here. Let's get this sorted. Alright, so the diagram shows line on top, neutral on the middle, earth on the bottom. Line, neutral, earth, okay. Line, they show the line going to the transformer, which is incorrect. Your line should always go first to your fuse, which we have an internal fuse here, and then it should go to the switch. And then your neutral should be connected to your windings and then come out to the switch. So that's a little boo-boo on their part. Yeah, the line, the switch and the fuse should always be on your line, and the fuse preferably first, which in this case it is. So for line, we're going to run a line from L line here up to the switch. So I have, let's see here, I have this. I'm going to use heat shrink on all the connections too, just because I have a mile of it. Generous viewer Mark gave me a whole bunch. Now I can use heat shrink on everything pretty much. So I'm just going to put our connection from line. It's going to be awkward doing this in front of a camera Bear with me, folks. So let's fold this over and wrap it and solder this one. Let's solder it this way. Okay, let's solder this one up. That's good. Now, these are our transformer windings, our primary transformer windings. We have two windings, and they're both 110 volts. If you read the thing here, it says red and black, 110 volts, 50 hertz. Red and black, 110 volts, 50 hertz. Now, for a transformer like this, that's wound for 50 hertz, you can run them on 60 hertz, no problem. It's just a higher frequency, which means there'll be less currents at 60 hertz instead of 50. Okay, so this is our neutral, and this will be our neutral connection. So let's cut some of these off. Don't need them that long. And let's strip this. They're going together, so we're going to wrap them as one. And let's feed it through. And wrap it around the lug. And solder that. Okay. Let's put our heat shrink on and shrink it now while we're here. Let's heat shrink these two. Okay. Now we need to route these wires back. Let me cut this somewhere here. Like that. These get routed back to the switch, but we're going to twist them. And twist them to reduce the AC hum that they'll generate. And I hope after twisting I have enough length to meet the switch. Okay, we're getting close. It should be okay. That's not very great. Okay, we'll go with this. Let me strip a little bit more off here. This one here, cut this, strip it. Okay. Now I'm going to use the Chinese switch. Yeah, I know you're groaning about it. But I'm going to remove these silly screw terminals and solder directly to the lug. Alright, so our heat shrink. And our heat shrink. Solder this one first. Okay. Now, the beauty about doing kit building is you can make it any way you want it. You can add your own parts, you can subtract parts, you can make it bare bones, you can make it all done up. You can put, like for example, these switches, you could pick out something nice. You can spend some good coin on a nice switch, illuminated. You can do all kinds of things. I'm just going with the basic stuff here. Okay, now for something else I'm going to add an YX2 capacitor. This is a 10 nanofarad, and it's going across the switch. So I'm just going to add this in across the switch and solder this one in place. Get this to cooperate. Not too much on there. Okay, that's good. Let's do the other side. Okay, that's in. Let's do our heat shrinking. Just make it a little more safer with the insulation. Alright, and we are done our primary. Alright, so all our primary windings, our wiring is done. I'm not impressed with this power switch they gave us. It is a big clunky thing, and it's actually in the way of the socket here. Just barely. I could probably make it work, but I'm just not pleased with this. They could have put a smaller switch in or something. Kind of limited in what switch I can use because the hole's already pre-drilled, right? So whatever, we'll use it. But I'm just gonna what I'm gonna do is take it out because it's in the way right now for what my next step is. Let's take this out, get it out of the way. I want to wire up these two sockets. If you look at the diagram, we have our 240 volt, 240 volts. So we got 480 volts center tapped. And you're using it as a full wave rectification. So here's our 0 center tap. That's our ground reference. And they're putting the 240 volts on these two plates here. And we have to light it up with a filament. We use a 6.3 winding. And what they're doing is using two tubes in parallel here. And they're wiring them in parallels to double their current handling capability. Would have kind of liked to see them just put regular diodes in there and be gone with all this tube stuff, but whatever. We're in here, we're going to do it this way. So what we have to do is we have to wire pins 1, 3, 4, 5, and 7 together on these two sockets. So I have to run jumpers from 1, 3, 4, 5, 7 to these from pin to pin, and I'll just use some hookup wire, and I'll get on that right now. And I don't think you need to watch me do it all. I'll parallel these up, and then I'll bring you back in. All right, so I wired up pins 1, 3, 4, 5, and 7 in parallel with the other socket. So they're all good. Now we can bring in our high voltage. Our high voltage is this winding here, and it goes to pin 1 and 7. So we can connect our green wires to pins 1 and 7. And let's cut them off. Let's see here. How does this... I'm trying to keep power and signal wires away from each other. Just maybe I'll do this. I'll go around, cut these off here. Should be long enough. And strip these back. And let's put these on pins 1 and 7. Come on, there we go. Okay, we can solder that one. Not the prettiest job here, but it's going to work. Okay. Let's do pin 7. Solder this one too. Okay, and we can solder these ones as well. There we go. Now, the center tap is already connected to my star ground, so we're good there. Now we need to bring in the 6.3 volt winding, which is, let's see here, I believe it's these two black wires. Black and black, 6.3 volts at 2 amps. Okay, so let's check this with an ohmmeter just to confirm. This is our 3.15. That's good. Okay. Should be nothing between these. Okay. This is our 6.3 volts. Let's twist this up. And this goes to pins 3 and 4. So what I'll do is I'll flow it around down under here and bring it up and cut my wires right about here. Okay, so we have our 6.3 filament winding coming up pins 3s and 4. So we got this one. I can solder this one now. We can solder this one. And I think that is absolutely it for filament winding, so we can do this side. And lastly, this one. Okay, so our rectified DC is going to come out on this blue wire. Pin 5 here, connected to pin 5, and pin 5 on here. And for that, we need our 6 watt 51 ohm resistor. So let's find that baby. 6 watt 270. Here's a 6 watt 51. Okay, let's test it, make sure it's bang on. Comes back at 50.5. Good enough. So I got my resistor here. I was going to connect it up to pin 5 on this and then terminate it on this terminal strip. Let's see if I can get this. So I can solder that one up. Okay, and then I'll just leave that one for now. That's going to terminate to that one. And then I need a wire from this one to here. I think I'll use this piece of wire. I should have mounted these caps opposite of each other. It would have made it a little easier, I think. And that is just too short. So I'll get another piece of wire. I'll use this stuff. This stuff is pretty thin. We're not dealing with heavy current here anyway, so I'll just use this. Actually, let's take off a little more than that. There we go. Let's wrap this. Let's wrap this. And have it come down to here. Okay. Put these two together in the same hole. Now, before I start soldering, I have my 180 ohm resistor that goes between the two caps. Let's see here. Let's put this on. Oh, you gotta be kidding me. Let's solder that one. Okay. Let's solder this one. That's our B plus right there. So I'm going to leave that open for now. Let's solder this one. Solder this one here down to the PC board. There we go. Now, I don't know how much wattage, these are 6 watt resistors, but I don't know how much wattage they're going to dissipate. So I just want to have them hanging out in in the open air like this, away from other components. And that is pretty much it. We have our power supply is wired and done. Now we have, I took the liberty and connected these two yellow wires. These are 3.15, 3.15. There's filament windings for these three tubes. I already connected these. So I have to bridge from this pins 3 and 4, or 4 and 5 actually. 4 and 5 to 4 and 5 to 4 and 5. So I'll bridge those next. Okay, now that the power supply is assembled, let's do some testing. This ohm meter, testing the power cord. Okay, we have an ohm meter here. You see that? Turning the switch on. Getting about 7.8, 7.5 ohms, which is good. Okay, let's try between this and the chassis. We got nothing. Okay, so let's populate these two rectifier tubes, and let's power it up for the first time. These are Chinese tubes, 6Z4. So I don't know anything more about that. I'm sure it's a high quality tube. Wow, these sockets are tight. Okay, where's the next one? Z4. Okay. Don't like those crunchy feel. It's not instilling confidence in me. These tubes have corrosion around the pins. Now you can see this. My camera will do it justice. I don't know if you can see the corrosion around the bottom of the pins, or the top of the pins there. See the green fuzz? Yeah, it looks like I might be buying tubes for this thing. I'm just trying to get it into the socket here, but it is really tight. I don't want to bust anything. Okay, I'll just leave it like that for now. Let's hook up a voltmeter to our B+. Let's see if I can do this. I can leave it lay like that. Okay, can you see this? Alright. So, plugging it in. And here's our watt meter. Turning it on. Went up to about 28 or so. It's hovering around 12. Voltage is coming up. Okay, we're on a 1000 volt scale here, so we are measuring just shy of 400 volts. 380. If I go to 300 volt scale, it pins it. Yeah, we're about 400 volts right now. 12 watts at idle. And dropping. So it's 11.9. 11.8. Just going to let this sit for about 5 minutes on power and see what it does. So it's been on for about 5 minutes now. It's stabilized around 11.6 watts for just this circuit. And I'm going to shut it off now, and I'm going to wait till that drops down. I'm not going to go near this until that discharges, so I'll just keep it on this meter. Okay, I'm glad I did this, because now I realize if I shut the amplifier off and the tube stops conducting, this thing will never discharge. It'll just sit there at that 300 and some volts. So I'm going to add a bleed resistor, and I did the math. 400k resistor will give me about 1 milliamp, and that's about half a watt, 4.42 watts or so. And I think that might be a little too slow. I don't want to put too low of a resistance in, because then it's generating its own heat and it's going to cause more heat and wasted power. So I think I'll go with somewhere between 220k and where can I go here? 220k or 330k, something like that. Something that's going to be a high value that's going to allow this to bleed down. I got 100k on there now, and it's still at 40 volts, and it's slowly dropping, but it's going to take its sweet time to bleed. I'd rather have it bleed down slowly than not at all, so I'm going to put a resistor in there. Let's wire up some of these output transformers, get rid of all this wiring here. So what I did is I just stripped this wire here a bit. I just pulled the insulation up about 1/4 inch. These are my 0 point for the output speakers, and I put the lugs so they're together, because they are going to get bound together. Just going to feed this wire through, and just so that makes contact there. This will go onto my star ground, and then we have the 0 point connection from the other transformer to come up here. I'm going to cut some of this off. It's a little long. Let's cut it off right there. Strip this off. And feed this one through as well. And we can solder that. Okay. This gets connected to the star ground. And trim off about this much. Do I have an open lug here? Yeah, I do. Can't see. Can you see? I can see. Okay. Doing this blind. I can't see. Okay, there we go. So that's in place. This down. Now, I'm not getting too crazy with making things look pretty here, so sorry to disappoint you. So for our 4 ohm taps, what is our 4 ohm taps? I don't know. These transformers were marked on the bottom, but I can't read them now. You could use an ohm meter. Look at this. Got our 2 blacks in the middle. Our 4 ohm taps are yellow, and our 8 ohm taps are green. So let's go with that. Yellow. This one here goes here. Let's cut this one right about here. I think I'm going to heat shrink these two. So let's get some heat shrink. I got lots to use up. As you can see, I got miles of it. Let's go with that. Put that on. our other channel. It goes up here, right to there. Let's cut it right about here. Okay, let's put these on. I hope you can see what I'm doing. Now, the green ones. A couple more pieces of this. Okay, green here. Let's cut that one there. And our last one is this channel. Over to right about here. Cut this one. Okay, that cleans up a lot of the wiring. Come on. Okay, now let's put these on. And I can heat shrink those in a bit here. Cut them quite long, didn't I? You almost think I wasn't paying for this stuff. Okay, so that's done. And then I'll zip tie these out of the way. And then that just leaves our primaries. We'll deal with that in a bit. Now, I did settle upon a resistor here. This is a 270K, 2 watt. So it shouldn't get too warm. I just put it on the last cap there, and that should be our good bleed down spot. And I've also ran grounds to these spots here on the terminal strip for the tubes. They need ground spots. And so I tied those back to the star ground, and then I also wired in the filament windings. They're the wires for the filaments on each tube, and we can solder that now since that's ready. All right. So keep this down and out of the way from the signals. This is a filament lead. Now I need to run a wire from number 2 pin here to number 2 pin here. That'll be our B plus feed from this. And I can run wires, I can run 2 separate wires, I think. Or I could run one wire and jumper to the next. I don't know if it makes a difference. But we're getting there. Another thing I can do is I can connect the primaries up. Red wire goes to pin 1. Blue wire goes to pin 2, as far as I can tell on these. So I can do that next. Yeah, maybe I'll do that next. I'll wire these primaries up and then I'll get our B plus in place. Alright, so I got the primary of the transformer wired right to pin 1. I think I can solder that in now. I don't think there's any reason for not soldering it. And same with the other side. Pin 1 is done. Okay. Blue goes to pin 2, and I also ran a blue wire from pin 2 on this socket up and over to pin 2 of this socket. So we can solder this one. That one's complete. Now we need to run this blue wire to pin 2. So I'll run this underneath. These are getting tight around by that star ground. And cut it to length right about here. And we'll put this here. Will it allow me? There we go. This one in. Wrap this one. Now we need to run a wire from pin 2 back to B plus. So let's see here. I got this one prepped. So we can run this under here. Run this to pin 2. Wrap it. Solder that one. And then we can connect our B plus up to the cap. Actually, I'm going to push this in. And then I can wrap this one. I didn't want to say anything, but this wire is kind of cheesy too. It's 22 gauge. I don't even think it's rated for 300 volts. This hookup wire, but we're using it. Okay, our B plus is connected. B plus on the cap to pin 2. Up and over to pin 2, both transformers are connected and soldered. Here's a look at the output wiring. That's why I put heat shrink on here, so I could push these up and out of the way, and they'd be out of the way for everything else. I don't have any fear of them contacting the chassis. So, and a couple of wire ties on there. I'm not dressing anything up right now, I'm just showing you what this looks like, so it's not too bad. I think it's okay. Alright, let's work on the input section. So we have 2 inputs. Upside down, this is red, which is right, right, left, left. So we have one channel here of left and right, one left and right here, and we have to. The switch is going to be our selector between the two. So let's wire this up so we can make it work. I'm going to use yellow wires for the left channel. So I'm too lazy to go get white. I'm going to use some of the scraps I cut off, so I'm just going to do this quick. And the other channel, the other selector. Come on. Okay. You want to fight with me, huh? Okay, and I'll just use red for the right channel. And this one. Okay, and I have a black one here cut up, ready to go. This is our ground from these grounds are isolated from the chassis, so I have to run a ground wire from this pair over to this pair. Probably be easier if I had that switch gone out of my way. Oh, this is going to be tricky. Hang on. Need to bend this to be more agreeable to what I want. There we go. Too much. Okay. Ah! I'm going to tin you. You won't do that again. Okay. Let's get it through the hole. That's all I want. Let's solder this side up. I think that's good. Flood it good with solder. Okay. I'll trim these and strip them now. I'll come right back. Alright, so I cut and stripped these wires, tin the ends, so it makes it easier in my life. So what I want to do is, when the switch is in the up position, I want to have these inputs active, and when it's down, this side's active. So we'll wire it that way. Switch is up, the left side active. Okay, so we are going to have to connect switches up. So this pin here, these two pins here are closed. So let's put our left on this side. This is a double pull, double throw switch, and it's actually two switches in one. You have three contacts on the left, three contacts on the right, and they're separate. There's no connection between those three and these three. But depending on which the switch position is, your center is your common, and it either toggles between this side or this side. So you can see that, I hope. There's a poor. Let me zoom in a little bit. Okay, so let's so this side here is going to be our active side. So let's put this here. This will be our left channel side, and this will be our right channel side. Okay, you can solder those two. Okay, and then the other one. Alright, other channel, same thing. Left goes on the bottom. See if I can bend those over. Once you tin them, they don't want to bend as easy. There we go. Solder these two. I noticed on this schematic there is no isolation DC blocking capacitor on the input. I'm thinking I might add one, but let's try it without first and we'll see. Okay, so our left and right for this channels, for this input is wired. Tuck these back out of the way. Tuck this one down here out of the way. And this one. Okay, so now we have our shielded cable. This is going to run from here to our volume pot, so we have to wire this one in as well. So the red goes on the right. Let's wrap that right around. And the white goes into here. You can solder these two. Okay. Let's solder these before they fall off. Okay. Now we need to get our ground wire on this lug here, the shield. Get it. It might not go through. I tinned it to make it easier, but now it's too thick. This is ridiculous. Let's take this out. Let's try this alone first. No. Let's cut a little bit off the end here. Okay, there it goes. And black wire. Isn't this fun? Struggling with... Come on, get in there. What's holding it up? It wants to play with my patience today. Okay, that's in. Come on. There we go. Okay, I'll fold this one over. Fold this one over. Ta-da! It's in there. Let's solder it. Okay. You're going to be able to see this. There we go. Okay. Let's cut off the excess. This side too, I guess. There. Alright, so there's our cable. I'm going to run this towards the volume pot. Let's just dress these wires a bit, make sure they're not shorted. Okay. Good. Alright, so on this side I want these wires at least that long. Yeah, that should be good right here. Alright. There's a ground shield. And then our two signal wires. Let's tin these ends. Okay, good. Alright, so they're marked. Let's see here. I'm pretty sure there's... Let me check this. There's L-A-N-D. L-A-N-D on each. That's the land. I guess that's your ground. And they should be connected together in the R. Okay. So we have ground on the outside of these. Turn this a bit so you can see it. You have ground, left out, right in, left in, ground. So I'm going to put the ground here through this hole. And I'm going to solder it so it doesn't pop out on me. Okay. Left is your white, red is your right. So let's insert these wires. Oops, wrong hole. Put that one there. do left. Solder that. Let's do right. Okay. Now with what's left of our cable, we have a short chunk of shielded cable here. We can use this as our connection from the volume pot to the preamplifier tube, or the first stage. So I'll get this prepped, I'll strip it, tin it, and we'll get it ready. Okay, I prepped the wire. One end I have my left, right, and ground. The other end I have left and right, ground's cut off. So we're going to run the ground from this side. And let's solder this. Now we need this is our right channel. And this would be our left. Okay. Great. Now we bring our signal wires in and we connect. Depends which amplifier you want to be right or left. I'm going to go left and right, so everything on this side will be right, and that is for pins 2. This will be a left channel here, pin 2, and pin 7, which will be our right channel. So we can connect the red wire up to the right channel. Very, very delicate operation here. Let's see if I can solder this. Okay. Get our there we go. Now if I wanted to put blocking capacitors, it would probably be between the potentiometer and these two tube socket pins, but we're going to run without it for now and see how it works. I'm mainly concerned about DC going back up through the jacks and into the preamplifier, but I think we're going to be okay here, so that's good. We're done. Alright, so we're getting near completion here. We've got everything wired. We have our primary mains wired. We have all our filament voltages wired. We have our power supply built and wired in. We have our outputs all connected, but I made a mistake. I have not added I still need to add a wire from the 8 ohm taps on both channels back here. This is our feedback line through an 18K resistor. I forgot to add a wire, so I'm going to have to add another wire to each of these taps here and run it back to the terminal strip for an 18K resistor. We have our input section all wired, our select switch and our 2 inputs, volume controls wired, and it runs up to the preamp tube. All that's left now is to complete the circuits with regards to running the components between the tube sockets and the terminal strips and any other jumpers I need. And then we're going to be ready to power up. So let's continue on. So let's start wiring our components in. First I'm going to start with these 330 nanofarad capacitors that go between the preamp stage and the output stage. Goes from pin 7, or actually from pin 6 to pin 7, and from pin 1 to pin 7. And we can use these right here. These are the ones in our kit. 400 volt caps. I'll come right back after I'm done prepping these. Okay, so we need one cap between pin 1 of this socket. Get a good bend on that. And pin 7. So that would be this pin here. Actually, I should have. This is. Okay. Let's leave this one here like this. Cut this off. This one here. Okay, that's good. Let's cut this one off. Okay. Let's see if I can wrap these better. Awfully thick wires on these. Okay, I think we got it. Okay, good. And our second one, I put a little sleeve on, so it's going to go all the way under here to pin 7. And this one here terminates at pin 6, I believe. Yes, it does. So let's cut this right about here. And wrap this one. And then we'll do this side. I'll wrap those better before I solder. Okay, so there's our two caps. This one fell out. Pin 7. Stay in there. There. Now on this pin 7 we're going to need a 470K to ground. On this pin 7 we need a 470K to ground. So let's get those 470Ks into place. Alright, got my 470K here. Put some sleeving on one end because we are going to go around some other pins. I just want to insulate it. Let's fold this one back. Goes around here, connects to ground. This is my ground right here. Okay, let's just dress this up and then solder it, because that's it for pins on this one. It's awful These capacitor leads are so thick and heavy. Can't bend them. Okay, I'll leave that alone. Let's solder this. Okay. I'll deal with that later, because we're going to need that tie point for some more action here. So let's move to the other one. What do we got here? Pin 7 on this socket here. It's pin 7. Wrap this. And this is going to go over to our grounds. Okay, leave that there. We can solder this one. Next step, we have a 100 microfarad cap and a 270 ohm from pin 8 to ground. And we have that on pin 3 to ground as well. So let's find those parts and put them on. Alright, I found the caps. These are 100 microfarad 50 volts, but the 270 ohm resistors are missing. Unless it's these ones. These are like 6 watts. I guess it has to be these. These are 6 watt. I didn't think it would be that heavy duty, but we're going to put these in, I guess. So here's our 2 resistors and 2 caps. I'll test these caps. Samyang. They're rated at 105C. Samyang NXB brand series. I'm going to see what's good or bad about these. They should be fine. Okay, I think I found a discrepancy here that's kind of got me scratching my head, and I think it's just a mistake on the wiring diagram here. They got this 270 ohm resistor connected to ground to pin 3 plus the 100 microfarad cap. Now on this side there's nothing connected to pin 3. These two should be identical because these are both your power amplifier tubes. They have it shown it connected to pin 8 instead. Unless there's something here that I'm not seeing. Maybe pin 3 and 8 are connected internally, I'm not sure. And if that's the case, then we can go this way. But I'm going to check the tube first and make sure that those pins are not connected. Alright, so I did check. Pin 3 is connected internally through the tube to pin 8, so we're going to use pin 8 over here. And I got this in position, got a little sleeving on it. And we're going to just fold this one back and use pin 8 as our connection point. And we'll leave pin 3 on this socket floating. There you go, that's good enough. A note on these resistors, they are not the highest quality. They're painted green, but that paint flakes off and it leaves the end cap exposed. And like for example, I can see on here the paint chipped off and I can see the metal cap. So you're going to make sure this is when it's like laying down here against the chassis. Make sure it's up a little bit so it can't contact the chassis, and that paint is not an ideal insulator either. These ones are close to ground potential. It's not as critical, but if you have a high voltage, for example this one here, you can create some arcing, which you don't want. These bloody leads are so difficult to bend. They're not made for point-to-point wiring. I think they're made for printed circuit boards. Okay, so I got my resistor here. I'm putting it on. I want to put these resistors up high. Remember, this is all upside down. I want to put these up high in case they dissipate heat. I don't want them being down low. So I'll put them up high. They can dissipate their heat and not bother the other components. These caps tested out fine too. Negative towards ground. So I'll put this in here as well and share the hole if it will fit. Might not. There we go. And this will go over to pin 3. Let's wrap this one up. Let's cut off some excess. Okay, that one's in, and let's check our diagram here. That's all there is to that pin. We can solder pin 3. And then we'll do pin 8 here. Come on. Okay, this resistor's in the way. What the hell? I start getting angry here. All right, let's solder this contraption up. Cut these short. There we go. Solder pin 8. And I think we can solder this ground connection here. We have, yes, let's solder this one. Let's solder this one. I just want to make sure this is up away from the chassis. Solder this ground. Okay, that side's done. We have to build a little power supply for this tube, and it's after B plus comes in through here, and then it goes through this 36K resistor, and it's filtered by this cap here, this 22 microfarad at 450 volts, which is to ground. And this is our supply for this tube through these 250K resistors to pins 6 and 1. So if we get 150K, pin 6 and 1, we can set this up so we can do that. Now, I could tap off of the B plus from either pin 2 on this socket or pin 2 on this socket. I doesn't think it really matters. They have it showing coming off of pin 2 of this socket to 36K, and then it goes to the capacitor, and this is our power supply for this. So we can do this here. I have the 36K right here, and let's tap it off of this pin. It's already soldered, but I'll just heat it and push it through, and then we can wrap it and do it properly. Come on. There's lots of room there. I know there is. Don't fight me. There we go. Okay, I'll leave that. Let's put this one through here. We use this one as our point. This one here gets wrapped up. Let's cut this. Pull this back a bit. Cut this off. I'll trim these all after. So that's our tap off point. Let's resolder this joint. Make sure it's good. And everything looks good. Let's put our capacitor on this side. This is ground. This is going to be our positive. Let's use one of these sticky pads. And we want our cap right here, so put it right here, I think. Perfect. And we'll put this in. Right there. Let's zip tie that. Okay, that's good. We can solder these two right off the bat. Let's cut this. Here's our little power supply. And now we have 150K, which is these two, and we run these from our little supply we just built to pin 6 and 1. So here's pin 1 to pin 6. Right here somewhere. Okay, we can solder that one. We have to bend this away from this other pin. Okay. Right in there. Okay, that's one resistor. The other one's pin 6. Let's have a little bit of sleeving on this one. It's good stuff, but I can never find the end of it. Where is it? Maybe I need it on a reel. Alright, pin 6 is this one with the capacitor. Is it? Yes. Let's solder this one. Should be able to fit a third wire through this hole. It's pretty big. There we go. Okay. That's it for that one. Are there any more connections here? We got the two 150s, 36. I think we're good. You can solder that. You can solder this one up. And we have our ground point here. We still have a couple of grounds to connect. We have a couple more components here. I think they are the 2Ks. They go to ground from pin 3, and pin 9 gets grounded too, I think. Does it show that on here? Doesn't show it on here. Pin 9. I don't think that's a ground connection. Maybe it is. They're running a ground from the potentiometer to the center pin, which isn't connected to anything. It's dud. And they're running that through. Might have to add a wire from the volume pot to ground here, because we're all isolated from ground with this. So I'll have to run one through. I'm not clear if that connects to pin 9 or not. It shows a dot there. And this schematic shows nothing. Okay, I'll think about that, but let's get these two 2K resistors in place from pins 3 and 8 to ground. Alright, here's our 2K resistors. I got one with the sleeve on. I'm going to go with the sleeve on this one, just because it goes around some pins. Feed this in and wrap it. And then this one goes around to ground. Just put it from the top. Okay, that's one. Wrap this better. Okay, and the other one goes from pin 8. Pin 8. I'm going to do this from below. I'm going to shove this one up here. And then, let's see if I can, right about there. And then the other side, get this out of the way. Come on. Okay, good. Well, they're crisscrossed like that, but that's okay. Leave that one there and solder it. That is their only pin connection, isn't it? No, we have our, this is our negative feedback line. From right here we got an 18K, so we need to add an 18K to that. And here's our 18K. And then we'll make our negative feedback over here. Let's put this underneath. put this underneath for now, and then this here can go over here. Pull this through. We're going to do this underneath. Dress that up better. Let's cut and tack this. Okay. So hold that steady for us, and then we can wrap this one. Cut here. How does that look? Pretty good. Let's solder it. I'm not trying to score points on appearance here. Set these up a little better. Okay. And our other feedback line comes from here, goes through 18K to pin 3. So we need an 18K between pin 3. Put some sleeve on this one. Pin 3. Solder that. Okay. Now this resistor can go up here to any one of these. And that will be our feedback for that channel. So this is done. I'll cut 2 wires going from the 8 ohm tap to the 18K resistor. Let's see if we can mount this way. And that'll be our feedback for the amplifier. I'll cut those and strip them. Alright, so what I did is I just added a wire to each of these 8 ohm taps here. A blue wire on this one and this one, and these are the wires, or this is left, I think, left and right. No, this is right and left. So let's just attach these. This one goes to the 18K resistor that I just finished installing. So put this one here. Wrap that there. This one here can be snuck around close to the ground plane and come up on this one here, and then we can wrap that and solder that. Okay, so that is it for connections, I do believe. Solder some of this up. Ground this one here, and this one here. Now, I was looking at the photo, and they do show a wire coming from the volume pot going up to the center pin and then to ground. So I'm going to add, actually what I'm going to do is I'm going to redo this connection here. I'm going to disconnect this because what I did is I cut the ground off. I really shouldn't have done that. So, really? What I'm going to do is I'm going to redo this connection, have the ground come out and go to the center pin, and then I can just jumper the center pin to my ground connection here, and then that will be done. Alright, I've got it stripped. I just want to tin this so it doesn't fray on me. And then let's strip these two. And tin these as well. Okay. Now, let's connect our ground connection to here. Let's just leave the ground connection loose for now because I'm going to add another wire. And which amplifier was left and right? I can't remember. This is the right one on this side. So let's add our wire. Okay, and then this side was our other channel. Okay, that's all connected. I'll just get a little piece of wire about that long, and I'll run it from the center pin to ground. Strip this. See if I can fit it in one of these holes. I should. There it goes. Okay, that's all done. You can solder the grounds. Let's solder these grounds. Solder this ground. And that's it. Everything's soldered. Okay, I think we're done. I was going to go through, snip some of these long wires and do some dressing, and then we'll come back and we'll check our work. So here's the hardware that's left over. Not these washers, but this stuff here. So we got some M3 screws and some M4 screws and some nuts, M3 nuts. Now none of these are long enough to mount the feet, so I had to go dig through my stash and pull out some other hardware that will work. These will be long enough, but these ones aren't, so I'm going to get busy and install these feet, and then we'll put it together. Okay, so I think I'm done because we're out of parts now. It's empty, except for little bits left over. Now, this knob they supplied, I'm not a really big fan of. It's a set screw knob, and this is a spline shaft. It doesn't really fit. When you put a set screw on a spline shaft, when you turn it, it's kind of off center and it looks goofy. So I'm going to put this in my knob stash. I have 3 here I got to pick from. This one here is the plastic knob. It's off some kind of a receiver or something. I'm not really a big fan of this. It's kind of like doesn't match the color very well, so that's out. These I got on Aliexpress. These are just generic knobs, brushed aluminum or machined aluminum. This one here is not bad, but it protrudes probably about 4 millimeters farther. I'd have to cut the shaft off about 4 millimeters to get that to snug up there tight and look good. I think I might, I don't know. And then there's this one. It's a lot smaller, but it fits a lot nicer. And it has a minimalist feel to it. I think I might just go with this one. Alright, so I got everything connected. We're about to go live for the first time. Get power here. Let's plug it in. Showing 0. Let's switch it on. I got it hooked up to 440 tone into the input. I think I have it on the correct one. Should be good. Let's turn it on. Goes up to about 50 watts and then comes back down. And remember, we've got 5 tubes now, so we're drawing 23 watts, 24 watts here. And here comes our tone. Pretty sure we got both channels here. Tubes are conducting and we went up to 58 watts. Okay, let's let this go for a while and see how it does. And then I'm going to hook up a load and we'll do some measurements. So just want to notice that we're running in Class A mode here because we're at 57 watts even when it's turned down, but when you turn it full volume it doesn't change. It stays the same. So and some heat radiating from these tubes. Alright, we're wired in for a power test. Let's put the power to this thing and see what kind of beans it's got. 1000 hertz tone. Let's try it out. Get the scope hooked up. Saw a big little transition there on the scope when I turned it on. Tubes are coming up. There we go. Okay, our triggering's not working. So let's keep going until we get clipping. It's actually doing a little better than I thought. This can't be. Keep going up. There we go. Looks like we hit the end of the volume knob. So let's turn up the signal. Let's give it a 2-volt signal. Still running out of steam. Let's give it 3 volts. That's actually about RMS, that's probably closer to 1 volt RMS. Let's keep going up. There we go, we got clipping there. Okay, so let's adjust this for 5 volts of division. Okay, let's figure where a clipping point is. Right there. Back it off. I'd say right about there. We got some distortion going on though. We were at 5.29 volts RMS on the left channel, which is the top, I believe. I'm going to let this go for a while. Power consumption doesn't change from 0 to full power. So, like I said, these Class A amplifiers, single-headed amps, they just consume lots of heat even when they're idling. It's nice. I don't see any ringing or oscillations, so I'm just going to leave it here for a while, let it cook, and come back in a bit. I just want to see how these transformers hold out. Getting some heat off the tubes. Okay, it's been going about 10 minutes now. These output transformers are still cold. I don't expect them to get warm anyway. They're pretty big, they're pretty bulky for the amount of power we're pushing through it. This is just starting to warm up. You can start to feel a little bit of warmth in it. It's really not doing anything. And these tubes are, well, they're as hot like you would expect them to be. So I'm just going to call that a wrap. So it's done, it's working. No problems building it other than some little bit of fitment problems with some screws, and I didn't like the hardware. If you're thinking of buying one of these kits, like I did, just to settle a curiosity I had, I really enjoyed building it, for one thing. And this is probably the cheapest kit I could find for what it's doing. They do make more advanced kits with more power, better tubes, I guess. I don't know. But this is the one that was the most budget. It was under $100, but then you're also going to pay another $100 to get it shipped from China to your house because of these big transformers. It's quite heavy. It's quite a heavy package. I enjoyed building it. I'm going to enjoy listening to it. I don't have too many gripes about the some of the things I don't like about it is the hardware they supplied. It's not really, you're going to want to replace it with your own hardware maybe. My other complaint about it is the filter capacitors they supplied with the kit. Don't think those are legitimate. I think they were just rejects that they bought up off somebody else and put them in the kit just to make it up. They will work, but I wasn't happy with their quality, so I turfed them and put new different ones in. Resistors, they're okay. They're the cheap Chinese resistors, but they are what they are, and they do work, so not much to take about that. The tubes, not pleased with the corrosion on the base of this one tube here. I can't remember which one it was, but we'll see how long that lasts. I'm gonna enjoy listening to this for the next little while, so thanks for watching. Hope you enjoyed the journey. And like I said, if you're thinking of getting one of these kits for yourself, they're pretty fun to build. I did enjoy it. Another thing that wasn't too pleased about was the punching of the chassis for the terminal strip. Couldn't get it to fit, but having to drill a couple holes through the stainless steel wasn't fun. My bits had a little struggle there too. Overall, I think it's a nice, attractive little kit with the stainless chassis and tubes on display, the black transformers. It all looks good, and the bottom's on. So I'm going to wrap this one up. Thanks for watching, and take care. We'll see you on the next one.